Okay, so first of all we're asked to integrate this and to come up with the expression on the screen. So integrate this, we're going to get 4k squared minus 1 times y squared over 2. Take away 32k squared, take away k y, between the limits 8 and k. Okay, so we substitute 8 in, we get 4k squared minus 1 over 2 times, put 8 in, I get 64, put k in, I get k squared. Take away 32 lots of k squared minus k, put 8 in, and then I put k in. Okay, so I've now got, this will factorize, let's take, okay, so I've got 4k squared minus 1 over 2 times 8 minus k, 8 plus k, take away k, that's going to help much, is it? 32 k squared minus k times 8 minus k. Okay, take a factor of 8 minus k out, which I know is in the answer anyway, and I'll take the half out. So half 8 minus k leaves me with 4k squared minus 1, which does factorise, I might come back to that, times 8 plus k, take away 32k squared minus k, oh, so 2 of those, because I've taken a half out, I have to do a double, 2 of those, okay. Be good to spot another factor at this point. That's 32k minus 1. Can't see an obvious one, I've got to be honest, but anyway, half 8 minus k. I think I'm going to expand now. Okay, so I get 32k squared plus 4k cubed minus 8 minus k minus 64k squared plus 2k. This is an 8.5. I mean, I know what I'm aiming for. Okay, so sorry. I was expecting the second bit to factorise. I forgot what the answer was I was aiming for. Minus 32k squared plus k minus 8. That's fine. So I was expecting this to factorise, and looking at the answer, it doesn't. So that's done. That's proved. Hence, find the value of k that gives a maximum value for the volume of the spinning top. Alright, so let's find the volume of the spinning top first. So the volume equals pi times the integral, we'll call C1 Y1, so x 1 if you like, squared dy, x1 relating to the circle, the curve C1, and that goes between k and 0 plus pi between 8 and k of x2 squared dy, that relates to this curve here, plus the volume of this cylinder, and it's got a radius of 1, so pi, radius of 1, is it? Yeah, half, oh, radius of half, sorry, pi r squared times the height, it's just pi. Okay, now let's look at x1 and x2 squared. So for the first curve, let's look at the equation. So for x1, I've got y1 equals k to the 2 over 3 x to the third. Okay, so I'm going to cube both sides. So y cubed equals k squared x. So x1 squared equals y to the 4, y to the 6 over k to the 4. And for y2, for y2, I want to rearrange that one. I'm going to get y times 4k squared minus 1 plus k minus 32k squared. All divided by 4k squared minus 1. Okay, and hopefully we can see that this is x2 squared. Just rearranging the second equation, which we can change slightly to give us 4k squared minus 1y minus 32k squared minus k all over 4k squared minus 1. Okay, so now if we look at it, you can see we've got this expression at the top here at the top, and this is just a factor. Okay, so the volume, let's plug into the formula. So the volume, go back to this line here, it's pi times the integral of x1 squared, which was y to the 6 over k to the 4, k and 0, pi times the integral from 8 to k of x2 squared, which is 4k squared minus 1 y I'll bring the factor of 4k squared minus 1 out so we can recognise it from earlier, and then we've got to add on pi. Now this first one is going to be y to the 7, so it's pi y to the 7 over 7k to the 4 between k and 0. The second one, we know the integral of this because we did it in part A earlier. So this equals pi over 4k squared minus 1 times an 8 minus k times 4k cubed okay, plus pi. So where are we going now? First part is pi k to the 7 over k to the 4 is k cubed over 7 plus this equals this, sorry, plus pi. Sorry, I've spotted a mistake again. We're rearranging this. This should be over 4k minus 32 here. This is not right. 4k minus 32. Badly rearranged. Okay, 4k minus 32. 4k minus 32. Okay, apologies for that. So now this has got a factor of k minus 8, which will cancel with that. So I get pi. Pi times k cubed over 7 plus pi times pi over 8 times minus 4k cubed. So divided by k minus 8 down here, so I'd make that negative. Plus 32k squared minus k plus 8 plus pi. Alright, finally I want to find the maximum volume. So I do dv by dx. So dv by dk equals 0, and I get 3k squared pi over 7 plus pi over 8 times minus 12k squared plus 64k minus 1 equals 0. Okay, so multiply everything by 56, and we get 24k squared. There's a pi here, isn't there? Sorry. 24k squared pi, though I can divide by pi clearly. Let me divide by pi. 24k squared, take away 84, let's say 84k squared plus 448k, take away 7 equals 0. Alright, so we get minus 60k squared plus 448k, take away 7 equals 0. Then we get, so that gives us, don't need to do anything with this one, k equals 7.451, or k equals 0.016, but we know that k is greater than a half, so we've got k equals 7.45. Okay, and then it says find the maximum volume of the spinning top. So we've got the equation for the volume, pi k cubed over 7 plus pi over 8 minus 4k cubed, 32k squared, take away k plus 8 plus pi, substitute in k is, so v equals 237 cubic centimeters to 3 significant figures.